Let's begin. Today's December 17th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 2, 9, 12, 16, 19, and 22. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our first digit, the triangle digit, and the Turing Machine will be comparing it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B will take a look at the 3-digit solution, and the Turing Machine will let us know how many 3s there are. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C will take a look at our first and last digits, triangle and circle, and compare them. Should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D again takes a look at our 3-digit solution, except this time the Turing Machine will let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card E will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F will take a look at our 3 digits, from triangle to square to circle, and the Turing Machine will let us know a little bit about the ordering of our digits. Should the digits appear in an ascending order, meaning that they are increasing, as in the example 135, or should the 3-digit code be in a descending order, or basically decreasing, as in the example 421, or alternatively, the 3-digit code may have no order. So let's take a look at the example of 231. Notice that it goes from 2 to 3, increasing, and then 3 to 1, decreasing. Of course, you could have a solution that's decreasing and then increasing, but it's basically that shift from one direction to the other that can define a 3-digit code as having no order. Now, we have seen in previous puzzles another scenario where if you have consecutive equal digits, as in the example 331, that can also exhibit no order. And the reason for that is, if you notice, when it goes from 3 to 3, there is no change. It neither increases nor decreases. So that's what I meant by a code that has consecutive equal digits. That is also another way to define a 3-digit code as having no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card D. Okay, so the Turing Machine does not approve of my choice. Notice that in criteria card D, we are finding the ratio of even to odds. In my proposal, I do have 2 odds to a single even, but because the Turing Machine does not approve of that, that must mean that there actually should be more even than odds. So let's go ahead and type that up in our notes in section D. And we'll just simply state that there should be more even than odds. Well, of course, that just means that we have at a minimum 2 evens and a single odd, or we could have an all-even solution. I think the next thing I'd like to test is criteria card E. Okay, so the Turing Machine does approve of my choice. Notice that at criteria card E, we are adding up the first 2 digits. So in my proposal, 3 plus 1 is 4. 4 is less than 6. So that means that the Turing Machine approves that the sum of the first 2 digits should actually be less than 6. So let's go ahead and type that up in our notes in section E. And we'll say that triangle plus square should be less than 6. And so what can we say about that? Well, if we want to assure that our sum of the first two digits is less than 6, then I believe neither can be a 5, because when you add 5 even to the smallest of 1, that already is 6. And of course, if you add anything bigger than 1 to 5, then that also would exceed 6. So yeah, we need to limit it to digits that are less than 4. And of course, another thing to keep in mind going forward is, in order for you to maintain that sum of 6, you really are sort of picking maybe small digits, although 4 and 1 will fit the bill. Let's see, what else can we test? So remember, we do have evens. There's nothing that doesn't say anything about duplicates, so you could have 2 2s maybe. As far as pairs go in both triangle and square, obviously 2 2 is the only thing that's possible. 3 3 is already 6, and you can't have 2 odds. So if we do have a pair of digits, it would have to be 2 2. Let's see, what else can we... Let's go ahead and test criteria card C. Let's compare our first 2 digits. Oops. Okay, so the Turing Machine does approve of my choice in triangle and circle, since we got that check mark. And I did pick an odd 3 for triangle and an even 4 for circle. Since 3 is less than 4, it must be true that triangle should be smaller than circle. So let's go ahead and type that up in our notes. And that's in section C. And again, we'll state that triangle should be less than circle. And so let's see what that reveals. If triangle is to be less than circle, I don't think circle could be a 1, because if circle were 1, there's nothing smaller for triangle to be. Okay, let's see, anything else? Yeah, I think that does it. Okay, well, we have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing our first digit, the triangle digit, to the number 3. We also didn't query how many 3s there are. Well, at this point, since we know that we have a majority of evens, if there is a 3, it can only occur 1 time. If at that, it could also be, there could be no 3s. And remember, we haven't really established whether we have 2 evens or 3 evens. So just because the 3 doesn't appear doesn't mean that it's all even. It could be a 1 or 5. Let's see. And we did not test criteria card F. Now, as I recall, I believe there may be a way to deduce what criteria card F is. And in conjunction with criteria card C, I think the argument is as follows, in that if we presume that the solution is in ascending order, meaning that they are increasing, then, and because remember, ascending does imply that the digits are increasing. They won't be consecutive equal digits. So they are all distinct and ever increasing. So if that's the case, then if it is ascending, then we would know definitively that the triangle digit would be smaller than the circle digit, making criteria card C irrelevant. Similarly, if our solution were descending, again, ever decreasing, all distinct, we would know that triangle would be greater than circle. And again, making criteria card C irrelevant. So I think we can safely deduce that the solution has no order. Okay, so we know we have no order. Let's see what else. We have two evens, and the sum has to be less than 6, and again, circle has to be greater than triangle. So let's see. And there are no, there's no mentioning that you can't pair up those evens. So that is interesting. So what can we do here? I wonder, perhaps maybe thinking in extremes. Obviously it is triangle. If we make triangle as big as possible, that would be a 4. And then the only way to maintain that sum to be less than 6 would be to make square a 1. Let's see. What else could we try? It could be that we have no 3s. Let's see, what else could we... Interesting. Again, I go back to, well, could we have a pair of 2s? Again, there's nothing that says they cannot be paired up. Could it be something like 2, 2, 4? Let's see, if it's 2, 2 and circles to be greater than, how would you pick between... I don't think it's going to be paired up 2, 2 because remember, circle has to be greater. So we'd have to pick from 3, 4, and 5. I guess criteria card B, the only viable possibility is there is a 3. Because if there is no 3, how would you pick between 4 and 5? You've already established you've got a majority of evens. And I don't see anything in our criteria cards to be able to distinguish between 4 and 5. So it could be 2, 2, 3. That's a possibility. What else is there? Could we restrict triangle to be less than 1, 4, 2? 1, 4, 2. It can't be 1, 4, 2, or actually can it? 1, 4. Maybe that's it. 1, 4. Well, but then what about that 3? 1, 4. It can be 1, 4, 3 because that would mean you have 2 odds. So of course you wouldn't have a 3. Very interesting. Let's go with 1, 4, 2. I'm not sure. I'm really having a hard time picking something. But just to double check, our first digit is smaller than the second. 1 is smaller than 2, not by much, but it still works. There are more evens. The sum is less than 6, and it has no order. All right. Let's see. What can we say? I'm wondering, of the 3 remaining criteria cards, are there... Well, we've already... defined what criteria card F is, so we don't actually have to test it. And so it really comes down to A and B. So let's see, can we deduce? Let's go ahead and let's test criteria card B. Well, let's see, if there are no 3s, there could be a 5. If there are no 3s, could it be a 1? Yeah, it still could be a 1. Let's go ahead and test criteria card B. Okay, so it does not approve of the absence. I don't have a 3 in my solution, in my proposal. So the Turing Machine does not approve of that. So it's actually saying that there should be a 3. So let's go ahead and type that up in our notes in B, and we'll say that we're going to deduce that the solution has a single 3. Okay, so because a majority of evens was established and there must be a 3, let's go ahead and then cross out all the remaining odds. So it can't be a 1 in triangle and square, and it can't be a 5 in circle. So that means we are looking at a 2, 3, 4 solution. Let's see. Well, that's true. I was saying, well, can we have a pair of evens? I guess that's still plausible. Let's see. And well, yeah, let's go ahead and test criteria card A. Okay, so it does approve. Notice that I did pick an odd 1. 1 is less than 3. So that is correct because the Turing Machine approves of that. So let's go ahead and type that up in our notes, and we'll say that triangle should be less than 3. So what does that say? Well, if it is less than 3, that means it has to be a 2 in triangle. So it can't be a 4 or a 5. Okay. And so that leaves only a 2 in triangle. That means that we can now cross out the 4 in square because 2 plus 4 is 6. We can't have a sum of 6. Both 2 and 3 work. We only have a single 3. So I don't think it could be 2. Well, 2, 3. Oh, yeah, it can't be 2, 3 because if it were 2, 3, 2, it would not be true. That circle would be greater. And it can't be 2, 3, 4 because that's ascending. So I don't think the 3 is going to work out in square, which means that since there has to be a 3, okay, it does seem to be a 2, 2, 3. Okay, so it did work out that way. I did not think it would. Well, let's type up our solution. It does seem to be 2, 2, 3. And let's do a quick review. Yes, it's true that the first digit is less than 3. The solution does have a single 3, yes. It is true that our first digit triangle is smaller than our last digit circle. Yeah, 2 is less than 3. There are more evens, and the sum is less than 6. And as I stated at the top of the video, when describing criteria card F, you can have a solution that has consecutive equal digits be in no order. Slightly different from the only example that they provide on the card. So yeah, that looks like it seems to work. So let's go verify that 223 is correct. Yes, fantastic. Okay, and how do we do versus the Turing Machine? Well, this is a 6 criteria card puzzle, and we only had to do 5 tests, so that's very promising. We did do CDE in the first round, and then we only had to do AB in the second because we outright deduced F. So let's go type that up, CDE in the first round. So C was correct, D was incorrect, E was correct. In the second round we did A, which was correct, and B was incorrect. And we outright deduced F. Well, fantastic. So we beat the Turing Machine by 2 questions. No doubt, in part, having to do with our deduction of criteria card F. And, we did get several check marks, which are always good. Looking back, criteria card A C, and E all have 3 different options. So again, we got very fortunate. We did get A correct, C correct, and E. So yeah, those 3 check marks saved us from having to retest either of those one additional time at least. But what about you? How did you solve it? What criteria cards did you choose? And did you discover anything interesting that you'd like to share? Please add those thoughts to the comments. If you liked the video, please do give it a thumbs up. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.